Hey, Algebra 2. Today we're going to learn about functions. So a function is a relationship between a set of inputs x and a set of outputs y. And so graphically, here's what a couple of them look like. A constant function would look something like this, a horizontal line. This particular one that I drew looks like the line y equals 4. That would be a constant function. A linear function is the equation of a line. This one that I drew is the line y equals x. We've done lots of quadratic functions, so that is an example of a quadratic function. Cubic function we haven't done yet. Here is the parent function, and that would be y equals x cubed. That's a cubic function. All right, so how can you tell that something is a function? A function will pass the vertical line test. VLT is vertical line test. So that means if you draw a vertical line anywhere through your function, the vertical line hits it at only one spot. So we have, okay, that's passing the vertical line test, passes the vertical line test, passes the vertical line test. So here is something that is not a function. If you took a parabola and you put it on its side, this is not a function, because when I draw a vertical line, it hits 2 points right there and there. So this fails your vertical line test. So what is it about it? So this one right here, that's the point, like we'll call that 2, 5. And this is the point at about 2, -2. And so if you were looking at maybe a table of values or something, what you would notice is that it fails and it's not a function because your x's repeat. So it's not a function because your x's repeat. All right, so once you know that, then when you look at this, your x's are 1, 2, and 1. So this one is also not a function, and it's not a function because the x's repeat. And if you would draw it, you would see a graph that gave you this kind of a situation where it would fail the vertical line test. So we're going to do everything all about functions today. Next we're going to do is we are going to evaluate a function. All right, so this says g of x equals that, and we want to find g of 3. So what you'll notice is right here where the x was, I put a -3. So anywhere that you see an x on the other side, you're going to replace it with whatever this number is here. So g of -3 equals 4 times -3 plus 2. So where that x was, I just plugged -3 in its spot. And then from here, we're just going to do our order of operations. All right, so that is -12 plus 2, g of -3 equals -10. All right, so what'd you do? You had to plug -3 in for the x. G of -3 is what we call function notation. It is not multiplication. That's supposed to say notation, not notion. Anyway, keep it going. And then you evaluate the number on the right. I'm going to do one more, and you can check some of the others on the notes. Let's jump around and do number 3 here. We want to find h of -1. All right, so I have to plug -1 in 2 spots now. So I have 2 times -1 squared plus 8 times -1. So sometimes when I put in a negative, sometimes students do not do the best job, but if you entered this exact string into your calculator, it would be able to handle it. I'm going to do it manually. I know that -1 squared is +1, and 8 times -1 is -8. h of -1, 2 times 1 is 2, 2 minus 8 is -6. That is how you evaluate a function. Here we have a fraction. I'll keep doing number 5 now. So I want to find f of -1. Okay, so I have 3 places that I have to plug it in now. So every place I see an x, I'm about ready to plug in -1. So -1 is going in there, there, and there. If you're plugging in a negative and you're about ready to square it, you have got to put parentheses around it. That is the number 1 thing that you should have learned. Over -1 minus 1. So here's what it looks like on step 1 with direct substitution. Do not put this in your calculator. Okay, so the numerator is one grouping symbol. You could stick that in your calculator. And the denominator is a separate grouping symbol, and you could stick that in your calculator. Okay, so -1 squared is 1. -6 times -1 is +6. 1 plus 6 plus 3. -1 minus 1 is -2. When I add the numerator, I get 10 divided by -2. And f of -1 equals -5. So that's how you substitute it in, do direct substitution, do the math, and then this can simplify, so I need you to simplify it. Number 6. So number 6, you just have to plug 20 in to 3 spots and then multiply it. Here, number 7, we have something a little bit different going on. We want to find g of 2 plus 7. All right, so let's find g of 2 first. So I have 7 times 2 minus 3. That's 14 minus 3 equals 11. But that's not what I want. I want to find g of 2 plus 7. So now I'm going to substitute. I know that the value of g of 2 equals 11. And then the 7 is just a number. There's no operation to do. And 11 plus 7 equals 18. This is something new, so let's do one more. Let's do number 8 right here. I want to find f of -5, and then after I do that, I'm going to subtract 3 from the answer. F of -5. So I have to plug -5 in 2 spots. -5 squared plus 6 times -5 minus 18. All right, so you have to watch your negatives. This negative out in front comes down, it stays there. The x is -5 itself, and that is the value that you're going to square. Order of operations, if you plug it in your calculator exactly like this, it'll handle it for you. Negative 5 squared is 25 times negative is negative 25. 6 times negative 5 is negative 30 minus 18. And when I stuck that in my calculator, I get negative 73. So I want to find f of negative 5 minus 3. All right, so I just found f of negative 5. I know that's negative 73. And then I have to subtract 3 from that, and I get negative 76. 9 and 10, you are just doing this twice, and then you're subtracting the answers from each other. So first I'm going to find f of 9. So I have 9 squared minus 9. That's 81 minus 9 equals 72. And then I need to find f of negative, that's just a 7, my bad, f of 7. So I have 7 squared minus 7, that's 49 minus 7 equals 42. So then when I find f of 9 minus f of 7, I have 72 minus 42, which equals 30. The next section, we're going to do operations on functions. So that says take your f function and add the g function to it. So I would rewrite this as f of x plus g of x. So if you have f plus g in parentheses, you can separate it out. And so here, you're just going to add your two functions together. Here you have f minus g of x. So the first thing I would do is I would separate it and rewrite it as f of x minus g of x. And I'm just going to subtract my two functions. That dot says multiply, so I'm going to rewrite it as f of x times g of x. And here you're just going to multiply your two functions. And this is division. I would rewrite it as f of x divided by g of x, and I'm just going to divide. So when it says evaluate each function, f plus g of x, so the first thing I would do is I would rewrite it as f of x plus g of x. And then after that, all you have to do is substitute. So f of x is represented by that. So I'm going to sub in x squared plus 7x plus 12. Bring down your plus sign. G of x is 3x minus 4. So 3x minus 4 goes in its spot. And then from there, CLT stands for combine like terms in my world. I'm going to combine like terms in standard form at the same time. So I don't have any other squared terms, so I have x squared. I'm going to combine like terms on my x's. 7x plus 3x adds up to 10x. And then I'm going to combine like terms with my constants. 12 minus 4 adds up to 8. Good final answer on that one. This says that you should subtract them. So you have to watch the subtraction ones. So f of x, I'm going to sub in x squared plus 7x plus 12. You bring down your minus sign. When I sub in my g of x, which is 3x minus 4, anytime you sub in multiple terms in place of 1, you have got to put that in parentheses, because if you have subtraction right here, the subtraction sign has to be distributed, and it's going to change both those signs. The most common error that people are going to do is they're not going to put it in parentheses, and they're accidentally just going to put negative 3x minus 4, and that's going to be a wrong answer. Right, so I have x squared plus 7x plus 12. Distributed, that goes negative 3x. Negative times negative goes plus 4. When I rewrite it in standard form and combine like terms, I have 7x minus 3x adds up to 4x. And for my constant, I have 12 plus 4, which adds up to 16. That's your good final answer on that one. 13, 14, 15, 16 is more of the same. I'm guessing you might need help on 14 when we have multiplication. So I'm going to rewrite this as f of x times g of x. All right, so I'm going to multiply these two functions together. So f of x is x squared plus 7x plus 12. G of x is still 3x minus 4. All right, so when you have multiplication and you substitute them in, you need to put each one of them in parentheses. Here, you have to remember how to distribute. So I'm going to start and I'm going to multiply every term in the first times every term in the second. So I'm going to start with x squared times 3x. When you multiply variables, you add exponents, so that becomes 3x to the third. And then I'm going to go x squared times negative 4, which is negative 4x squared. Now I'm going to move to my 7x and distribute it. 7x times 3x. So 7 times 3 is 21. X times x is x squared. So when there's no exponent, you have to remember that there's an invisible 1, and when you multiply variables, you add your exponents. 7x times negative 4 is negative 28x. Now move to the 12. 12 times 3x is 36x, and 12 times negative 4 is negative 48. Now I'm going to go through and combine like terms. Like terms are defined as having the same variable and the same exponent. So when I do that, so I'm going to add my x squareds together, and you just add their coefficients. So I don't have any other x cubed, so you just bring that down. Negative 4 plus 21 adds up to 17 x squared. So remember, when you combine like terms, your variable and exponent are unchanged. 28x, negative 28 plus 38 adds up to 8x. And then you don't have any other constant, so that's all you have. Ooh, the table defines some linear function. Which of the following defines f? All right, so here's a couple things that you can do. So you could just go in and you could plug 1, 2, 3, and 4 into all of these. That is a valid idea. I'm going to teach you a little something. All right, so your ends just go up 1, 2, 3, 4. But your answers, these are your y's. So your y's are changing. So let's see if we can find a pattern. So when I go from negative 2 to 1, that went up by 3. When I went from 1 to 4, also went up by 3. 4 to 7 also went up by 3. All right. So I can tell that this is a linear function, and I can tell that because you have to add 3 to get your next y value. And whatever you are adding right there is your slope. So this has a slope of 3. So you have to remember that's in the form of y equals mx plus b, and your slope is your m. So I basically have y equals 3x plus I'm not sure what. All right, so this one, there's no number, so that's an invisible 1. So that one has a slope of 1. This has a slope of 2. This has a slope of 3. And this has a slope of 4. This is the only one with a slope of 3, so C is the answer. And we're going to do 18 and 19. This says, given h of x is negative x plus 5, solve for x when h of x equals 3. When it does it like that, so now you'll notice that the 3 is not here where the x is, the 3 is over here. So this means my answer equals 3, and I am going to solve for x. So h of x equals 3. So I'm going to use substitution. I learned a long time ago that if I block things in, so like these rectangles are the same thing, so I'm going to get rid of this rectangle and I'm going to substitute 3 in its spot. So when I do that, now I just have a linear equation. I'm going to solve for x. So I'm going to subtract the 5 over. 3 minus 5 equals negative 2. I have to solve for x, so I have to get rid of that negative out in front. So that means I'm going to have to divide both sides by negative 1. And that's how I get 2 equals x. All right, same thing on 19. I have g of x equals 4. So I know my answer equals 4, and I have to solve for the x. So I'm going to substitute 4 in place of the g of x, and everything on the other side stays the same. Now this is a two-step equation, so you need to subtract the 9 over. Negative 5 equals negative 4x. I'm going to divide both sides by negative 4. Negative divided by negative goes positive. So 5/4 equals x. Thank you so much.